got a couple of third problems that we're going to have a look at today. So let's have a look at what we got. Obviously, if you feel like pausing at any point to have a go at the question and then re-go and see what I've got and see if we get the same answer. So the first one we got here, it says, if the dots are 1 centimetre apart, what is the total length of the blue rectangle? So by the total length, we want the perimeter. What's the perimeter of that blue rectangle? Now, as it says they're 1 centimetre apart, so basically it's saying that the dots are 1 centimetre apart that way and 1 centimetre apart that way. So if we look at this bit here, if we go up there, across there, we can make a right angle triangle. Not a very good straight line, but never mind. We can see that that is 3, and that is 3. So we're going to find the length of this bit. We're going to call this A. So that's Pythagoras' theorem. So we just use Pythagoras. A squared equals 3 squared plus 3 squared. So in this case, A squared equals, well, 3 squared is 9, plus 9 is 18. So the length of A is going to be square root of 18. So we've got the length of A in third form. So let's have a look. We're also going to have the other length of the rectangle is going to be B. So again, we can come across here and go down here, and we can see that this one is 4, this one is 4. So in this case, B squared equals 4 squared plus 4 squared. So B squared is going to equal 16 and 16, which is 32. So B equals square root 32. Now we're after all the way around, so we've obviously got the other two sides as well, A and B, exactly the same. So we got the length we want is 2A plus 2B, which in this case is going to equal 2 times root 18 plus 2 times root 32. Well, here we're going to have, well, root 18 is root 2 times root 9, so that's going to be 2 times root 2 times root 9 plus, on this one we can have 2 times root 16 root 2. 16 times 2 is 32. So root 9 we know, root 16 we know. So root 9 is 3. 3 times 2 is 6. So that's going to be 6 root 2 plus, and on this side, root 16 is 4. 2 4s are 8. So that's going to be 8 root 2. We're just adding 6 root 2's to 8 root 2's. So we've got a total of 14 root 2. And that is the length all the way around. Okay. This is quite a good question because you could alter this a little bit if you wanted to. So instead of going at 45 degrees there, you could have gone for some sort of a angle like that, couldn't you? And we could create a square down here, and in something like that you're then going to have to look at triangle like that, and it'll get a little bit more complicated. So I'll leave you to have a play with them sort of questions yourself and have a think what that might be. But let's have a look at another problem which we've got. This one, we've got a square. It's a side of 10 centimetres. We'll cut the corners off to make a regular octagon. How far should the cut be made from the corner of the square? So, there you go. So the square is the green bit. It's 10 by 10. And you cut the corners off and we make a regular octagon. And it's a little bit hard at first. You might not begin to see where to start with this one. But I would start with thinking, right, well, what's the side of an octagon? Well, this bit here is the side of the octagon. Let's go for red again. So we'll make that side A. Well, the diagonal bit there is also going to be length A. This is going to be length A. It's going to be length A all the way around. It's a regular octagon all the way around over side A. Now that's one length we need to find. But it's not the one that we're after. The bit we're actually after is this bit here, which I'm going to call length B. And that's from both sides. So B is the length we're going to come in to cut. Length A is the length of the octagon, and B again is the side to the corner. So if we look at that, we can make an equation out of this. So, because we're going to have A plus 2B is going to equal 10, because it's 10 centimetres long. So we can get A in terms of B, or we can get B in terms of A, but that's all we've got at the moment. So we'll call that equation 1. And I think we're going to have to find a second one. And we can get B and A in terms of each other again. If we look at the triangle, we've got B going that way, we have length B that way, we've got A there. And using Pythagoras, we can have B squared plus B squared equals A squared. So we can simplify that. We're going to have 2 lots of B squared equals A squared. Okay, make sure you think of it like that, because the temptation for some people would be to think, oh, if I square root the whole lot, I'm going to have B plus B equals A, which is not going to happen. You've got 2B squared equals A squared. Now we can square root it, and we'll have the square root of 2B squared equals A. Now, this bit we should know our surd rule. So square root of 2B squared is the same as the square root of 2 times the square root of B squared. So that will just be B times root 2 equals A. And I'm going to make that equation 2. So I've now got an equation at the top, and I've got a second equation here, and for simultaneous equations, this time I'm going to use substitution method. I'm just going to substitute A into there. So A equals B root 2. So I'm going to take equation 1, and I'm going to have, so if I write equation 1 out again, I've got A plus 2B equals 10. Well, A is B root 2, so B times root 2 plus 2B equals 10. This, again, I think the square root confuses a lot of students at this point, but if we've got a B here and a B here, we can factorise. Yeah, we can put it into brackets. We can take the B out, so we can have B multiplied by root 2 plus 2 equals 10. So now we can find out what b is, because we can divide by this. We can divide by the bracket. So b will equal 10 over root 2 plus 2. Now I'm just going to put a little line down so I can come up here. Just put a little to separate it all out. Then I'll carry on at the top there. So we've got b equals 10 over root 2 plus 2. Now we don't like square roots on the bottom with surds. We've got to rationalise the denominator. And this is one of those tricky ones. We've got root 2 plus 2. Normally if you just got the root, you can multiply by the root over the root and get rid of it. But we've got root 2 plus 2. So what we've got to multiply by is root 2 minus 2. And that will help us. So what we'll have is b equals, I'll write that bit, we've got 10 over root 2 plus 2, and we're going to multiply that by root 2 minus 2, root 2 minus 2. I'll put them in brackets so we can see what we got. So on the top, yeah, our numerator is just going to be 10 times that bracket, so 10 times each term of the bracket. So 10 times root 2, we're going to have 10 root 2. And we're going to have minus 10 times minus 2 is 20. So 10 root 2 minus 20 on the top, and on the bottom we've got a double bracket that we're going to expand. So root 2 times root 2 is just going to give us 2. Root 2 times minus 2 will give us minus root 2. Plus 2 times root 2 will give us plus root 2. So those two will cancel out, and we will have 2 times minus 2, which is minus 4. So we've got 2 minus 4. So that will all equal 10 root 2 minus 20 all over minus 2. Now we're going to simply divide by the minus 2. So 10 divided by minus 2 gives us minus 5. So we've got minus 5 root 2 here. And minus 20 divided by minus 2 will give us plus 10. Well, I don't like the negatives at the front, so we'll swap those two around. It makes it a little bit easier. So we'll have 10 minus 5 root 2. And then all we've got to do is think, well, actually we can factorize that as well. 5 goes into both of them. So if I take 5 out of the brackets, on this side I'm going to have 2 minus root 2. And there we go. Now that's quite a good one, because it's you look at it and you think, well, what am I going to do? It doesn't tell you have a clue where to start. So you've got to, if you haven't got a clue where to start, put some algebra in. Start thinking, start labeling sides with letters and see what you get. And in this case, it came up with, we had to get some simultaneous equations. So we've got 2 equations. It made sense to do substitution. Most people want to go for elimination method, but substitution method is the best way. And then it's just a lot of playing about with the algebra after that. So it's factorizing it, rationalizing the denominator, and rearranging it, and just getting it into a nice form. So it's quite a tricky question, that.